They're all reasonably easy to pick up. I had some trouble with a few of them, but for the most part, you shouldn't have any trouble getting what you need. The first thing I'm going to be using, probably the largest thing, is this ceramic bowl, pot, vessel thing. Daniel would have actually used a copper vessel, not unlike that, but made entirely of copper. Ceramic will work just as well. It's a glazed ceramic, so there's no big worry there. But it's best to use glass, plastic, but preferably glass. Going inside that, and what will actually be holding the zinc sulfate, is this contraption here, which I actually had to make rather. Daniel described what he used in the vessel, the larger copper vessel, as a earthenware jar. And basically the point of using an earthenware jar is that it's free, or it leaves room, if unglazed, leaves room for ions to pass through from sulfate to sulfate. However, in this case, a paper tube will do just as well. The problem, of course, is that you somehow have to seal off the bottom so that the sulfates don't mix while they're in the vessel. I've read that you can do plaster of Paris. I didn't have that on hand, but what I did have is paraffin wax, which is used for a number of different things, often for sealing jars of jam and that sort of thing. So all I did was melt some paraffin wax, poured it in a bowl, and then stood the toilet paper roll upright in it. And you can see that it actually completely sealed it off so that nothing is going to get in there, and it has a fair bit of weight, so it'll sink right to the bottom of the vessel. For the copper sulfate, I learned that you can get a product at pet stores called Copper Safe, which is actually used to treat fish parasites in fish tanks. It's called Copper Safe, and it's about $8 or so, and that's just straight up copper sulfate, so that's what I'll be using for that. As far as the copper electrode goes, I mean, anything copper will work. I picked up just an elbow from Canadian Tire for copper plumbing for about 96 cents. As far as the zinc side of things go, zinc sulfate is preferable, so I have, of course, a jar of zinc sulfate here obtained through the Dalhousie Chemistry Department, kindly provided to me. So that'll obviously have to be mixed with water, and that's what I'll use for the zinc sulfate. And for the zinc electrode, a zinc-coated screw. Now, to actually hook up to a light bulb and a multimeter, I will be using jumper cables. I only needed about 4, but I got forced into buying 10 from Radio Shack, but that's okay, they only cost about $6. And finally, I have in here a very little light bulb. I'm sure things much weaker than this battery will be able to light it up, but it's kind of nice to see something actually get lit up by your hard work and experimentation. So that's what I'll be using. Other than that, I'll be using a multimeter just to read the output current from this battery. I don't have it on me right now, but you know what it looks like. So here's the currently finished product. The Daniell Cell battery, a very crude imitation, but should work just the same. I actually scrapped the original idea I had for the main vessel, the ceramic pot, in favor of something that's taller and narrower. My fear was that I didn't have a whole lot of sulfate. As you can see, the bottle's pretty small, and I had to fill a fairly big space. In retrospect, it was a really bad idea to even think about using something this big. It should have been just a very narrow vessel. But I didn't have a whole lot of chance to do that. So I scrapped it in favor of this. So you can see the copper sulfate all at the bottom here, the blue. I actually mixed it with water, which, according to Daniel, is all right. He said a strong solution. So there's, I mean,